Okay, so every year the U.S. releases to the public a large data set containing information on births recorded in the country. This data set has been of interest to medical researchers who are studying the relation between habits and practices of expectant mothers and the birth of their children. This is a random sample of 1,000 cases from the data set released in 2014, and here are the variables. For this example, this video example, I'm going to conduct a multiple linear regression where you predict weeks until birth, which is the third variable here, weeks, by father's age, which is variable 1, mother's age, which is variable 2, and smokes, which is variable 11. We got to go look at that smokes variable. So let's go here. If I go into smokes and I click on the value labels, I can see I've had 3 levels of this categorical variable. So NA and non-smoker and smoker. I want to see how many we have in each of these categories. So let's go do a quick frequencies. I've already done it. Let me take that out. Let's just look at smokes and say, okay. And so I have 19 for whom it is NA, and 867 for whom they are non-smokers, and 114 smokers. That's a very unequal sample size or balance. It's out of balance, right? We have the preponderance of them are non-smokers. But for the sake of demonstration, I'm going to go ahead and create a new variable, and we're just going to do 2 levels because NA and non-smoker to me are the same thing. That it's not applicable or they don't smoke. So I'm going to combine those. All right, so that's coded as 1, and this is coded as 2, and then smoker is coded as 3. So I would like to see the smokers in relation to the non-smokers. So we're going to make these the 0 and smokers the 1. So let's go into transform, recode into a different variable. We're going to call it smokes, and I'm going to call it recode smokes. Change the name, go into old and new values. I'm going to say, I want smokers to be the 1. So if the value is 3, I'm going to make that 1. And I'm going to say, so I said value is 3, made it 1, and click add. And then I'm going to say all other values are going to be 0. Okay, so now what I'm telling it, I'm going to say continue. I'm going to say okay, go back and look at my data. And I have a bunch of zeros. Let's just do a quick frequencies on that. Make sure we did it right. And so I'm going to go, I'll look at these next to each other. All right, so now we have, if I add this and 19, I get 886 non-smokers and 114 smokers. Just for the sake of keeping things tidy, we'll go ahead and say 0 non-smoker, 1 smoker. Okay, add. All right, so the parents married or not, that's for homework. You're going to conduct a multiple linear regression where you predict an infant weight, which is variable 6, by the weeks till birth, variable 3, visits to hospital, variable 4, and parents married or not. Let's go ahead. I'm going to show you how to do that. All right, so we have this variable married. We have 1 is married and 2 is not married. Let's see how many we have of each. We can go to descriptives, frequencies, got married and already selected, say okay. And we have fairly balanced, not exactly, but close enough. So we're going to make married our reference category, so we're going to call those 0 and the not married the 1. So let's go to transform, recode into different variable, reset it. I'm going to pick married, and I'm going to call it recode married, change it, old and new values. So if they were 1, we're going to make them 0, and if they're 2, we're going to make them 1. Continue. Okay, let's do a quick frequency again on the new variable. Well, let's leave that guy in there. Recode married. Okay. Okay, so now the marrieds are 0s. and the not marrieds are ones. So let's go and label it really quick. 0 not married, 1 not married. Okay, and that's just for later. All right, so this regression that I want to run, I want to conduct a multiple linear regression where I predict weeks until birth by father's age, mother's age, and smokes. Okay, so we go to Analyze, Regression, Linear. Let me reset. I'm going to do weeks as my dependent variable, father's age, mother's age, and the new coded smokes. We're going to ask for descriptives, collinearity diagnostics. We'll go ahead and ask for Durbin-Watson and confidence intervals. Continue. We're going to ask for the Z predicted as the X, the resid as the Y, histogram, normal probability plot, and partial plots. Continue. We're going to ask it to save the cooks. Continue. And the options we just leave. Okay, so we get our output, and we can see, the first thing I want to do is see if we have a significant regression, and we do not. We can see 0.07, it's not less than 0.05, so we have a fairly small F statistic, but we'll just go ahead and continue and evaluate all of our assumptions and make our conclusion. So the first thing I'm going to look at is our variance inflation factor, because it's the first thing that comes up, and we can see that we're far less than 10, so we're okay. We'll come down, we look at our residuals. So our standardized residuals, we kind of fail that assumption. We're beyond -3 here, but we're within +3. And then our cooks is less than 1, so we're okay. Our histogram is not normal, so we fail that assumption. And then here we have our regression. We want this to be you know, just kind of a non-pattern blob of scatter points. And we can see that we have definitely patterns to this data, and then we have this one out here. So that fails the assumption of homoskedasticity, equal variances. We don't have that. And that's okay, because we don't have a significant regression anyway. So the first partial plot, weeks till birth and father's age, I'm not seeing a whole lot of linear relationship there, but here we might have a little bit of a linear relationship between weeks till birth and mother's age. And then obviously for the dichotomous variable, we don't evaluate those partial plots. All right, so let's go and look at our coefficients. All right, assuming we had a significant regression, the weeks till birth, right, for those who don't smoke is 39 weeks, right? And for those who do smoke, you would subtract 0.695. So they have the more tendency toward preterm birth than for smoking mothers than for non-smoking mothers. For every unit increase in father's age, they have tend to be a little bit more preterm. And then for every unit increase in mother's age, it's pretty negligible because it's close to 0, but it would increase. So we can't really evaluate these because it wasn't significant, but I wanted to show you how to do it just in case it were. So you would write that up. For your homework, you're going to do it, but you're going to conduct a multiple linear regression where you predict infant weight, variable 6, by weeks till birth, visits to hospital, and parents married or not, and you're going to have to recode that one. I've showed you how in the video, but I'm not going to give it to you recoded. You have to do it. Okay.